Question that I woke up to this morning that says, I'm looking down here, they're confused on number 12 and 19 on how to get after the first step. So here is my work on 12. So with this one, what I have done here is I have remembered my advanced identity. Well, okay, so in the first step, I know that x squared plus y squared is equal to r squared. So that's an easy substitution right here. And then I know that for every x, I know that x is equal to r cosine theta. So therefore x squared would be squaring that whole thing, r squared cosine squared theta. And y, likewise, is r sine theta, so y squared becomes r squared sine squared. I factored out the 4, well, no, the 4 was there. I factored out the r squared, so here's that. And then I see this, and I remember this is a property. I remember that this is one of the identities that we learned earlier this year. So I pulled up all of the identities that you need to be familiar with. So that's the great thing about this is that Polar requires you to remember the trig that you learned earlier this year. So in particular, what we were using, I just forgot, cosine squared minus sine squared right there. When I come over here, I see cosine squared minus sine squared is equal to cosine of 2u. So cosine squared u minus sine squared u is equal to cosine of 2u. Therefore, what I can do here, cosine squared theta minus sine squared theta is equal to cosine of 2 theta. Therefore, and I also divided away this r squared from both sides. We talked in the video before about how you can't do that in rectangular, but you can do it in polar. So this jump was using a trig identity, and then from here to here with the r squareds, we divided both sides by r squared. There was also a question on number 19. Let's see if I can see that one. On this one, sorry, let's see if I can get to there. Oh, that's not what I wanted. Oh well, sorry. Okay, there we go. That's a little bit better. So they gave us this cosine of 3 theta. Well, we don't really want to, we don't have x and y in terms of something besides just cosine theta, sine theta. So what we need to do is we need to break that down so that it's all in terms of just regular theta. So we know that 3 theta right here is equal to theta plus 2 theta. And when I come over here, I forgot. Okay, it's cosine that we're looking at. So I want to come over here to this formula and use the fact that cosine u plus v is equal to cosine, that's the one I remember, cosine, cosine, sine, sine, with the opposite sig in. Remember how we talked about that before? So cosine of theta plus 2 theta is going to be equal to cosine theta times cosine 2 theta minus sine of theta times sine of 2 theta, which is what I wrote here. Okay, now at that point, I was able to use the double angle identity on both of these places right here. So we'd already talked about the cosine double angle right here. And then here's the sine double angle. So 2 sine theta cosine, so sine of 2 theta is equal to 2 sine theta cosine theta. So now we've got everybody in terms of just just boring old theta. So there's no 3 theta, there's no 2 theta. And I can kind of clean things up from there. Then once I've got this in terms of r cosine theta, I can substitute in x. And if I have things in terms of r sine theta, I can substitute in y. And this is where they would stop at that point. Hope that was helpful. Let me know if you still have questions.